Well, welcome back, calculus students. I wish I could be there with you today. We got an exciting lesson for today. Now that we've finished parametric equations, we're ready to move on to the next topic of this unit, which is polar coordinates. Polar coordinates, something that you studied in pre-calculus. Today, we are going to quickly recap polar from pre-calc, and then we are also going to do a little bit of calculus with polar coordinates towards the end of the lesson. All right. So real quick, what's due today? WebAssign 10.2. Obviously, I'm not here to check it, but hopefully you're making good progress on that. Don't forget that will be due online tomorrow morning. So if you haven't finished yet, or if you still have some questions, you have until tomorrow morning to get that turned in. Tonight's homework, WebAssign 10.3 and 10.4a. They're combined together because we are covering both of those sections today virtually. 10.3 is going to be the review, intro to polar coordinates. 10.4a is where we get into the calculus of polar coordinates. And here's the big news. I wish I was here to celebrate with you, but believe it or not, this is the last WebAssign of the school year. I know, crushed, right? I can only imagine the cheering or tears of sadness. Is it tears of sadness or tears of joy? I don't know. That's going on right now. I wish I could see your faces while I gave you that news. Yes, last WebAssign of the year. That'll be due tomorrow. All right. So if you haven't already, go ahead, get out your notes. I'm going to pull mine up here. Give me one sec. Here we go. Polar coordinates 10.3. All right. I wish I was there with you to discuss this, but I do want to take this time, just give you 30 seconds to chit chat with some of the people sitting around you. What do you remember about polar coordinates from pre-calculus? Okay. What we're going to do is I'm going to spin around in my chair. When I've finished spinning around, I'm going to go again. But here we go. Right now, with your partners, what do you remember about polar coordinates? Okay, great, 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 great. Hopefully, it's lots of positive memories, so much excitement. I can only imagine. I can only imagine how thrilled we are. So let's do some polar, okay? So what's the whole idea behind polar? Well, the normal coordinate system that we're used to, x's and y's, um, so 2020 one. I don't know. What's a long time ago? We're in the modern era here, all right? Instead of using X's and Y's, we use R's and thetas now. R measures distance from the origin. Think like a radius, and then theta gives you an angle. It's just a different way of putting coordinates on a graph. Okay, so let's plot 2 points just to get an idea of what this would look like here. So I'm going to draw little axes here. That's a little crooked. I don't want that. Okay, so my first point is 1 comma pi over 3. So first of all, I'm going to go an angle of pi over 3, which puts you somewhere in the first quadrant, right? So there's pi over 3. And then I'm going to go a distance of 1 unit from the origin, all right? So let's pretend like that's about one unit from the origin, and that point right there, that is the point 1 comma pi over 3. That's it. All right. What about the other coordinate? Negative 2 comma 3 pi over 2. So again, I didn't write it for the first one, but the first number is your r, the second number is your theta. So this time our r is negative 2 and our theta is 3 pi over 2. So let's do the angle first, 3 pi over 2. That takes us down to the bottom, right? 3 pi over 2, you can think about that as 270 degrees. There's theta equals 3 pi over 2. Now, r is negative 2. Well, what does it mean for your distance to be negative? And here's a big rule when it comes to polar coordinates. When your r is negative, you go in the opposite direction. So 3 pi over 2 is normally sending you down, right? But if r is negative, we're going to go in the opposite direction and we're going to go up instead. So we're going to go up 2 units, and that's going to put us somewhere up here. You can imagine I'm going a distance 2 units up. That puts me up here, r negative 2 theta 3 pi over 2. So even though normally we would think about that as being like pi over 2, right? But since r was negative, that sent us in the opposite direction. All right. So that's how we plot the points. Next up, this is probably what you spent quite a bit of time doing in pre-calculus, is converting from polar to Cartesian and then Cartesian to polar. So here's a couple formulas, two for each. We're going to use each of these in just a sec, okay? So rather than me reading you the formulas, let's just go ahead and let's give these a try in some examples, okay? So here we go. Change these points to polar coordinates. Well, the first point is negative one, no, sorry, 1 comma negative 1. So 1 is your x, negative 1 is your y. We want to turn this into an r and a theta. Okay, so here we go. I'm going to write the point 1, negative 1. To get the r, here's the formula we use. R squared equals x squared plus y squared. So x squared, that's just 1 squared. Y squared is negative 1 squared. That's just 1 plus 1, right? So 2, which means r could be plus or minus the square root of 2. Yes, do make sure you have that plus or minus. We're going to need both the positive and the negative in just a sec. Now to get theta. We got r, let's get theta. Here's our second formula. Tangent theta equals y over x. So the y here is negative 1. X is positive 1. So this is negative 1. So I asked myself, when does theta equal negative 1? Well, could happen in a couple places. It could happen in the second quadrant. It could also happen in the fourth quadrant. However, I'm only going to go with the fourth quadrant, 7 pi over 4. Here's why. Only the fourth quadrant, since the original point 1, negative 1 is in the fourth quadrant. So even though tangent equals negative 1 in 2 quadrants, I'm picking the quadrant that the original point was in, which in this case is the fourth quadrant. So here we go. My first answer, you're going to see I actually have 2 answers to this, is if r is positive, square root of 2, then theta is 7 pi over 4. So I mentioned there's actually 2 answers here. Or, and this is how WebAssign is it's also going to ask for a second point where r is negative. So here's where I'm going to use r is negative square root of 2. Remember, if r is negative, go in the opposite direction. So what is in the opposite direction of 7 pi over 4? 7 pi over 4 is in the fourth quadrant. Directly opposite that would be in the second quadrant. This is where we'll say 3 pi over 4. When your r is negative, go in the opposite direction. Perfect. Okay. There's a second point. You're going to do that in just a sec. I want to do one more altogether, and it's one more at the bottom here. This time we're going in the opposite direction. They give us the r and the theta. We give the x and the y. Okay? So here we go. The first one. 4 comma negative 5 pi over 4. To go from polar to Cartesian, x is r cosine theta. That's a formula you want to have memorized. R is 4 cosine negative 5 pi over 4. We're going to flex our unit circle muscles here. Negative 5 pi over 4 is in the second quadrant, I believe. And cosine is negative in the second quadrant. So this will be 4 times negative root 2 over 2. So this goes in negative 2 root 2, I believe. Yes. So that's my x. Time to do the y. Y is r sine theta. X is r cosine theta. Y is r sine theta. So this will be 4 sine negative 5 pi over 4. Sine is positive in quadrant 2 for root 2 over 2. This will end up with 2 root 2. So our final answer here, we got our x, we got our y, negative 2 root 2, comma, 2 root 2. Box that. So you'll notice for the first question we did, we had two possible answers. For this one, we only have one possible, and that is correct. That is how these problems work. Okay? So I'm going to give you guys a couple minutes. Go ahead, do the second point for each of these, okay? Negative 1, comma 1 over the square root of 3, and 2, comma pi over 3. All right, I'm going to set a timer, come back in a couple minutes, go over some answers. All right, welcome back, everybody. So looking at the first question here, r squared equals negative 1 squared plus 1 over the square root of 3 squared. That should give us 4/3. When you square root that, you'll get plus or minus 2 over the square root of 3. When you do tangent of theta equals y over x, you'll get negative root 3 over 3 for that. And I'm specifically thinking about the second quadrant here. Why second quadrant? Well, it's because the original point, negative 1 comma 1 over the square root of 3, that's in the second quadrant. So when does tangent equal negative root 3 over 3 in the second quadrant? That's 5 pi over 6. So my final answer, 2 points, positive r, 2 over the square root of 3, 5 pi over 6, and then a negative r, negative 2 over the square root of 3. What is opposite 5 pi over 6 is 11 pi over 6. That's in the fourth quadrant. And then for the other question, this is going the other way. I feel like these ones are a little bit more straightforward. It's just x equals r cosine theta, y equals r sine theta. 1 for your x, square root of 3 for your y. So your 1 point, singular point is 1 comma the square root of 3. All right. I apologize if it feels like we're going a little bit fast. Unfortunately, we got to go a little fast through these so that we can get to the calculus as soon as possible. Okay. Now, a little bit more review to do here before we get to the calculus. A couple of graphs that you should have memorized. Okay. R equals 1 to start with. Well, what's this going to look like? This is the set of all points. I'll write it out in words. Set of points with a radius equal to 1. Well, what's this going to look like? Well, this is just a circle with a radius of 1 here. Let's see, I'm drawing it. That's r equals 1. So in general, r equals a number, r equals k, where k could be anything. K could be 5, k could be 500. This is just a circle with a radius equal to k. We like circles a lot. We use them a lot in polar graphs. All right, here's another graph that we should memorize. Theta equals a number. What's this going to look like? Well, this is the set of points where not r equals a number. Instead, this is theta equals 1, and specifically 1 radian. We're talking about an angle here. All the points that share that angle of 1 radian. Well, first of all, what is 1 radian even like? Well, I always think pi over 3 is really close to 1 radian, right? Because pi divided by 3, 3.14 divided by 3, it's just a little bit more than 1. So pi over 3 is really close to 1 radian. Theta equals 1 is basically just a straight line through that theta equals 1 radian. So this is theta equals 1 right there. It's just a straight line. So theta equals k. This is a line at theta equals k radians. So if you see r equals a number, if you see k equals a number, right away you should go, Mr. Goble, I know what those are. Those are a circle and a straight line. Now, what about the graphs that are not just circles and straight lines? Now, I understand in pre-calc you probably made some very impressive tables plotting points. We're going to do just one of these together. Now, before anybody gets too worried about using a lot of points, I promise you we are going to keep the number of points that we need here to the bare minimum. Okay, so here's what we're going to do. We're going to graph this 1 plus sine theta. I guess I should say r equals 1 plus sine theta. R equals 1 plus sine theta. We're going to do this with just 5 points, okay? So before anybody starts a riot, 5 points only. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And they're the easy points as well. So what's r going to be in each of these? Well, if theta is 0, 1 plus sine of 0, right? That's just 1 plus 0, which is 1. Theta equals pi over 2. That's 1 plus 1. Theta equals pi. Sine of pi is 0. You're back to 1 plus 0. Here, sine of 3 pi over 2, actually, I'm going to say minus 1, right? Because sine of 3 pi over 2 is negative 1. And then we're back to 1 plus 0 is 1. So let's plot these points on the graph here. Theta equals 0, r equals 1. You got a point right here. Theta equals pi over 2. R is 2. You got a point up there at the top. When theta equals pi, we got a point here at 1. When 3 pi over 2, r is 0. So that's actually a point right here at the origin, because r equals 0 is going to put you at the origin no matter what direction you face. And then at 2 pi, you're back to 1, right? Back to where you started. So we got 4 points here. We just kind of need to get an idea of how to fill in the rest of it. And we're not going to plot any more points. We're just going to think about this logically. In between 1 and 2, right? R is going to be 1 plus a number between 0 and 1, right? Because when theta is in between 0 and pi over 2, sine of theta is going to be between 0 and 1, right? Sine is going to be a positive number, can't be bigger than 1. And basically the same thing here, 1 plus a number between 0 and 1. So I could fill in the top half of my graph here. It's going to look a little something like this here. Do a better job on that one. There we go. R is a number between 1 and 2, and then between 2 and 1. Now, down here, now R is basically going to be 1 minus a number between 0 and 1, right? Because now uh, sine of a number between pi and 3 pi over 2, that's going to give you a negative number. So we're going to be subtracting now. Same thing here. 1 minus, I'll just put the little quotes here. It's the same thing. 1 minus a number between 0 and 1. So our R is going to be a number between 0 and 1 here. 1 minus a number between 0 and 1 gives you a number between 0 and 1. And so we can fill in the bottom half of our graph. We get a little something like this. We call this a cardioid because it looks like an upside down heart. Fantastic. Okay, for this next one, we are not going to plot points. We're going to do something a little bit different. We're actually going to do two graphs. So we're not going to just do r equals 2 cosine theta. We're going to actually do r equals 2 sine theta as well. So two graphs. Instead of plotting points, we're actually going to use our graphing calculator. Did you know that your graphing calculator can plot polar equations? Maybe you did, maybe you didn't. I'm going to show you right here. If you have a calculator, you could try it. Otherwise, you could just watch the screen. Give me 1 sec. I'm going to change my screen here. All right, so here's, hopefully you're looking at my graphing calculator on my screen. What I'm going to do is I'm actually going to click, here, let me zoom in a little bit. I'm going to click on mode, okay? Click on mode, and your whole life, what is this? The 1, 2, 3, 4, fifth option, we've been living in function mode. Well, to the right of function is parametric. We don't want that. We want polar. So go ahead, click on polar, hit enter. Okay, so I've changed from function mode to polar mode. Now I'm going to hit y equals. And look at that. Now instead of y equals, it's actually r equals. And so what I'm going to do is I'm going to type in 2 cosine theta. I'll zoom in a little bit here. 2 cosine theta. That's my blue graph. And then here we'll also do 2 sine theta while we're at it. So 2 sine theta. And to get the theta, I'm just hitting the X button like you normally would when you graph. Instead of X, we've got a theta. And check this out. When I go to graph it, there you go. Mine zoomed in a little bit. I played with it before the recording started. You might have to zoom in. But there you go. You can see your two polar graphs. The blue one is the cosine graph. The red one is the sine graph. And so what these are, I'm going to go ahead and change screens back to the notes here, is both of these are circles. So give me 1 sec while I change my screen back. All right. So as we were saying, these are both circles, okay? So let's start with the first one. R equals 2 cosine theta. Here's what I'm going to say is not just 2 cosine theta, but R equals K cosine theta, where K could be any number. This is what I like to call a horizontal circle with a diameter equal to K. So over here on the graph, 2 cosine theta, what this is going to look like is a circle with a diameter of K, or in this case, 2. So here is 2 cosine theta. This is R equals 2 cosine theta. All right. It's horizontal. It's on the x-axis. Yeah, so another word for horizontal on the x-axis with a diameter equals to K. That means the other one, R equals K sine theta. I'm going to call this a vertical circle with diameter equal to K. So here we go. Let's see. So this one is going to go up to the top. Doing my best to make them look like circles and not ovals. They should be circles. So do your best to make it look like a circle. That's r equals 2 sine theta. All right. There we go. And I will say you should memorize these graphs as well. Along with the k equals a number and or r equals k and theta equals k from the last slide, you should also know what r equals k cosine of theta and r equals k sine theta look like. Okay? Woo! Again, I apologize for having to go fast, but hopefully this was a review. This was just catching you up on stuff that you did last year. With that in mind, we actually are going to do a little bit more here. This was 10.3. We're also going to look at 10.4a, which is the actual calculus of polar coordinates. Luckily for us, it's pretty short. It's just 2 questions, okay? So go ahead, turn the page. We are mostly focusing on tangent lines. Here are the equations for the first derivative and the second derivative in polar coordinates. Now, when you look at these 2 equations here, you should be thinking, huh, that looks awfully familiar. That looks like the parametric equations, right? dy d theta over dx d theta. It's basically the same thing. It's just instead of dt's, we've got d thetas, all right? dy dx is the slope of the tangent line, not dr d theta. Dr d theta would be the rate of change of the radius. All right. We could also talk about horizontal and vertical tangents, right? Horizontal tangents happen when the slope equals 0. Vertical tangents happen when the slope does not exist, just like with just like with parametrics. Okay. So same ideas as before from last week, just with polar this time. Okay, so we're going to do 1 question all together, and then I'll have you guys try the second, and that'll be it for today. Okay, so find the slope of the tangent line to r equals 2 cosine of theta, and theta equals pi over 4. First thing we need to do is we need to get x, we need to get y. Okay, so here we go. We're going to use those conversion formulas. X equals r cosine theta. And here we go. This is r right here that they gave us. So just multiply the r that they gave you with cosine theta. So I'll have 2 cosine theta, 2 cosine theta minus cosine squared theta. That's my x. It's just the r times cosine of theta. What we're going to do next is we're going to take the derivative of that with respect to theta. Okay? So I'll have negative 2 sine of theta. Here's a great opportunity to review chain rule here. Minus 2 cosine theta, and then chain rule says take the derivative of the inside, which is going to make a negative sine theta. All right. Then we're going to do the exact same thing with the y coordinates this time. Okay. Y equals r sine theta. So take the original r that they gave us, multiply it by sine theta. So this time I'll have 2 sine theta minus cosine theta sine theta. And we're going to take the derivative of that with respect to theta. So the derivative of 2 sine theta is 2 cosine theta. Now we have a chance to review product rule. Leave the first one alone. Take the derivative of the second. So the derivative of sine is cosine. Now I'm going to take the derivative of the first. For the first, I'm going to say that's negative cosine. So what's the derivative of negative cosine? That's going to give you positive sine times the second one. Just leave it alone. So here we go. We got dx d theta, we got dy d theta. What I'm going to do now is I'm going to plug in pi over 4 into each of these. All right, so let's see. I guess I could write it right next to it. I'll do it right over here. So dx d theta, let me move it up a little bit to the top. Dx d theta when theta equals pi over 4. All right, again, time to flex some unit circle here. So -2 sine theta. We're back to dx d theta, plugging in pi over 4. So I'll have -2. What's sine of pi over 4? That's √2 over 2 minus 2 √2 over 2. And then we got negative √2 over 2. Whole bunch of cleaning up to do here. This is negative √2. Let's see, negative negative is going to make a positive. Plus, let's see, those twos cancel out. And then I think that's just plus 1. Yeah, because √2 times √2 is 2. 2 divided by 2 is 1. Negative negative makes a positive. And we're going to do the exact same thing for dy d theta. Plug in theta equals pi over 4 to that one. So here we go. Make some extra space here. 2 times √2 over 2 minus √2 over 2. It's really √2 over 2 squared, right? Because it's cosine cosine. So I'm just going to say √2 over 2 squared. And guess what? Wait, this is also √2 over 2 squared because it's sine theta sine theta. So √2 over 2 squared. And well, those are just going to cancel each other out. You end up with just a √2 here. All right, here we go. We got dx d theta when theta is pi over 4. We got dy d theta when theta equals pi over 4. Ready for our final answer. Dy dx when theta equals pi over 4 is just dy d theta over dx d theta when theta equals pi over 4. So I'm going to take my two answers. The y goes on top. The x goes on the bottom. And there we go. And I will say, if you gave me that answer on one of my tests, that's perfect. Um, you don't have to do anything else. I will say, just for the sake of multiple choice, this is a good chance to just briefly touch on rationalizing. If this was multiple choice, there is a chance they could rationalize it. How we would rationalize this is multiply the top and bottom by 1, or here we'll say positive, yeah, positive √2 plus 1. Positive √2 plus 1. If you multiply top and bottom by that, that would give us, up on top, you'll have 2 plus √2. And on the bottom, think of that as being like a difference of squares. You're going to have 2 minus √2 plus √2 plus 1. Um, or sorry, -2 plus 1. Yeah, -2. -2 plus 1, because it's negative √2 times positive √2. So on the bottom, we've got that's just a -1. Up on top, you got a 2 plus a √2. So you could also call this -2 plus square root of 2, which is equivalent. Again, you don't have to do that on my tests. I'm saying purely for the sake of multiple choice, you might see that written that way. All right. Fantastic, fantastic. So summarizing, I got x, I got y using r cosine theta, r sine theta. I took those derivatives. I plugged in pi over 4 to each of those, and then put the y on top of the x. There's your slope. Okay. And I will let you guys, let's take a few minutes to let you go ahead and try number 2 here. All right. So I'm going to set a timer again, let you guys work. All right, welcome back, everybody. Quickly go over this question and we'll be all finished. You can see I calculated x, that's r cosine theta. So literally just the r that they have here multiplied by cosine theta. Distribute the cosine theta to the 1 and to the sine. Then I took its derivative, making sure to use the product rule. And then we plug in pi over 3. Lots of unit circle. I did kind of combined some like terms here. Ended up with negative root 3 minus 1 all over 2. The reason why I combine the like terms is we can get a very nice clean answer to this if we simplify as we go along. For the y's, sine theta plus sine squared theta, basically just multiplying the r with the sine theta. Take that derivative. You have to use the chain rule there. When you plug in pi over 3, you'll get 1 plus root 3 over 2. And so you'll notice the dy d theta and dx d theta, they're the exact same thing. It's just the dx d theta is the negative version. So when you divide them, dy d theta over dx d theta, the exact same number, just one of them's negative, we get our final answer. Our slope is -1 here. All right. If you want to see more in depth the simplifying, again, this video is posted to YouTube, Google Classroom. You can go back and view it at any point. But I think that's where we're going to call it for today. Just a reminder, WebAssign, the one that was due today, you still have 24 hours to get that submitted online. But the main one, based off of what we did today, is 10.3 and 10.4a. That will be due tomorrow. Look forward to seeing you guys soon and have a good one.